All right. Hopefully we got audio this time. Yeah. All right. So let's play around with jbuttons. So let me close this out. So let's make a new project, and I will call it, I don't know, let's go. And I'm going to make a new other, and I'm going to go down to Window Builder, and I'm going to go to Swing Designer, and I'm going to do a J-frame. And I'm going to call it main because I'm out of imaginative names. And so there's our basic frame. I'm going to drop an absolute layout manager in there, or no manager. And so let's look at the things we can do with, say, a J button. So I'll drop this in here, right? And when you drop a button, the text field is highlighted. So if you start typing right here, it'll set the name of the button accordingly. But that's a field down here that we can modify. So we'll call it big button. And every time that we do something over here, right, it maps to something that happens in the code here. So I actually named my button something weird. So it named my button based on what I typed in the original text of the button, right? I may not want a button named button. So I'm gonna come over here and I'm gonna change the name of the button under variable, and I'll call this button 1. So now I have a J button called button 1, which is constructed with a text field. Yeah, I know, it's my favorite variable name too. It's constructed with a string, which will be its label, and there's the location and dimensions, and it gets added to the J panel. All right, so everything we did with the label, we can do with this also. We can come in and we can change different properties. We can change the background color. We can change the foreground. We can change the font. We could make the font bigger, so we could use a slightly bigger font and make our button bigger. So there's our big button, and so on. And you can, go to advanced properties and see some other things you can change. So we can, set up a border if we want, and all the stuff that we looked at yesterday, right? And everything, again, that we do here corresponds to something over here. So there's a default font for buttons, but when we changed the font, it created a line of code that said set the font to a new font, which is, the font name dialog, the style is bold, and the size is 96. And font is a class, and if you look at the constructor in the Java documentation, there's a way to construct it with these 3 arguments. You can see what that does. And so this whole thing, the new font, blah, blah, that is an object of type font, which is a suitable argument to the set font method, which is a method in the button, which is a J button. Right? So this is PA2 stuff, right? It's using methods inside objects that are objects of a certain class which go with another class, and so on and so forth. So we'll make this a little more reasonable. So I can change that to 24, and then we've got, something more civilized. So we can set all of those properties in here, and we can set them in code, or we can set them in this tool. So let's look at events. That was properties. Let's look at events. So let me right click on this and say add event handler. So depending on the type of widget, some of these events may mean different things. So certainly for a button, we can do action performed. That means the button has been clicked, right? So we've already played with that. So I'm not gonna mess with that too much. Let's look at focus. So focus gained. There's a notion of focus, which is if you were to type what event or window or object is going to receive those keystrokes. So, you know, in a typical Windows system, you might have a text window here, and you might have a browser bar over there, right? And different things can have the focus. Well, same thing in this this widget that we're building. So I'm going to drop a second button in here. And let's play around with seeing who has focus. So let me just drop another button over here. And let me drop a text field in here. Alright, so let's go back to our big button and let's add an event for focus. And we'll say focus gained. And so it created what's called a listener. So listeners are basically ways that we can register our interest in something, right? So if we want to respond to a mouse click on our object, we can say add a listener for a mouse click. And it basically says to, you know, something that's managing these events, something like an operating system or Swing, right? Hey, when you get a mouse click, this person over here wants to know, right? So here we're saying, let's add a focus listener. So there's a part of the system that tracks who has focus, which component has focus at which time, and when that focus changes. And here we're saying, hey, if we become a new, you know, if we gain focus, I want you to call the following method. And so we can write a method here called focus gained, and this will be called when that button gets focus. So let's play with this. So I'll put this over here. So if I click on this edit box, this has focus, right? Typing goes into here. If I click on this button has focus. Now typing letters doesn't do anything, but hitting the space bar on a button with focus will click it, right? That's how you live without a mouse. If I come up here, right, that just gained focus. You can also change focus usually by hitting the tab key. So right now I can hit a tab and my edit box will have focus. If I hit another tab, this button will have focus. If I hit tab again, it'll go back to the big button and I'll get another message saying focus gained. And now that's the one that has focus. So you can play with that. Let's play with keys. Let's look at the key pressed method. So I'll add a method for key pressed, and again we're adding another type of listener. In this case it's a key listener, and we're adding it to button 1. So button 1 has a method called add key listener that basically takes something called a key adapter, and part of a key adapter includes a method called key pressed. And key pressed will be executed on our behalf whenever we press a key while that button has focus. So if I come in here, I can hit a letter and, you know, or a number or anything else, and I'm not clicking the button unless I hit a space. Space is special. If you space on a button with focus, it'll click it. But, you know, any key that I hit, it's firing my event. All right, so when I press a key, this key pressed method is called, and it's given an argument, which is named E here, and it's an argument of type key event. So if you look at the key event documentation, right, it's an input event, which is a component event, which is an abstract windowing toolkit event, which is an event object, which is an object, right? So lots of extensions. But if you look at the methods available in this key event, those are all statics that are defined up there. We have some methods like, you know, get key character, get key code, get key location, get key modifiers, get key text, and so on and so forth. So in addition to knowing that we're sitting in here and a key was pressed, we can look at this object E that was passed and get some information about why we ended up here. So so let's expand that. So now when we come in here, I'm going to say key pressed, excuse me, code equals, and I'll call the get key code method on this object E. And then I'll say character equals, and I'll call the get key character. So let's bring this over here. So let's give focus. And if I hit an A key, it tells me code is 65, character is A. If I hit a B, code is 66, character is B. So this is giving me something like ASCII codes and characters like I would expect. So here's some numbers, and those are ASCII codes. Here's a space bar, that's a space, ASCII code 32. But if I hit the shift key, it tells me code 16. So normally, you know, something like fgets in C, you can't tell if the person has hit the shift button. Well, here we can. If I hit the control button, it tells me code 17. If I hit alt, it's code 18. If I hit the Windows key, it's code 524. So I can pick up things that aren't necessarily generating characters. By using these key codes. So if I hold down shift and press A, it tells me the character is A. The key code is still 65, but the previous key code was 16. So I could detect that the shift key was pressed by seeing code 16, and I could tell when it's released by putting in a listener for key released. And then I'd know when the A is pressed, should it be uppercase or lowercase. Well, it's keeping track of that for me. I don't have to do that. But if for some reason I want to break it down to that level of detail myself, I can do that. Right? So this is about making this information available to the programmer. If you don't want to use it, you can ignore it. But it's kind of cool to be able to pick up, you know, the Windows key and do something in response to that, if you like. So there's also a method called get key text. And get key text takes an argument, which is a key code, and this is a static method. So get key text is not something that I would invoke with like e.getKeyText. But I can invoke it statically by saying the name of this thing, which is key event dot get key text, and then I have to pass it an integer, which is a key code. Well, the key code I want is the key code corresponding to this event, so I'm going to do e dot get key code like that. And now if I run this, when I hit a key, like there's an A key, there's a 1. If I hit my shift key, it says shift. There's control, there's Windows, there's escape, there's F1, there's my up arrow, down arrow, and so on and so forth. It doesn't capture print screen. Capture scroll lock, and it captures pause. So it's pretty good. Right, home, insert, delete, end. All right, now you may not need to use this, but you know, it's there. Can you explain some of the syntax? Why is there a method declaration in the argument for a method? Yes, I can. Let's get to that. So first of all, let's look at this, right? So this is classic objects, right? Static method, name of a class, dot, static method, argument, which is the name of an object, dot, instance method, right? So this returns an int, that's an argument to this. This says concatenated to a string, so it calls this thing's toString method, which changes it into a string, concatenates that. That's an argument to print line, which is in out, which is in system. There's a lot of layering going on here, right? And to try to do this from scratch, nightmare material. But once we're comfortable kind of using and abusing this hierarchy of objects and classes, right, this just starts to flow out. So yeah, let's look at this weird syntax. So add key listener. Let's look at a J button. And let's look at the add key listener, which inherits from component. So add key listener takes an argument of type key listener, right? It's an object of that type. So when we say J button, button 1, button 1's the name of our button, button 1 dot add key listener should be adding a object of type key listener. Well, it's constructing a key adapter, which is a type of key listener, right? And what we could do is we could make a separate class, which would be a key adapter, and we could, you know, define it to have some methods inside, and then we could construct one of those, and we could pass that object as the argument to our add key listener. That's kind of a pain. So there's this notion of an inner class, which is when you define one class inside another. And that's one thing that's going on here. We're actually defining a class, but we're actually defining it as an argument to a method. And so this is actually an anonymous inner class. There's no name for this object that we're creating and this class that we're constructing, right? We're making a key adapter. And then right here we're listing the body of that class. And the body is written such that it contains a single method, which is called keyPressed. And that method is sitting right here. And so this curly bracket is the end of the body of that class declaration. And so we made a new key adapter with that body, and this parentheses matches that parentheses. All of that class definition is inside the argument to this method. So that's an inner class, and they're a little confusing to write yourself. It's one of the things that IDEs are good for, is, you know, when you need one of these, Eclipse just sort of fills it in for you. And we're just left with this magic code, and all we have to do is you know, put our stuff right there. Override is kind of funny. It keeps things happy. It's saying that we're defining our own version of focus gained. Now since we're creating a focus adapter, there's other methods that are already defined and have default behaviors. But we're specifically defining our own version of focus gained, and so override is in here just to say this is overriding a method that already exists in the base class. So this will work perfectly fine without this, but it goes into documentation and such. But you know, you can take that out and it works perfectly fine. If we have time, maybe tomorrow I'll actually go through an example of how you do this without using an inner class. How you actually define a separate class and write your methods in there and then tie that together. And it's actually pretty succinct, but it's easier to do from the command line instead of making more classes up here and so on. All right, so we can pick up key presses. We can and you know, you can go back to your code with this kind of thing, as you'd expect. So we can pick up key presses in fairly fine-grained detail, right? Much more than just, you know, getting the character that was pressed. We can find out how that character was pressed. We looked at mouse. We looked at mouse entered and mouse exited, right? So we can respond to those. Let's take a look at mouse motion. So let's do mouse moved. And that brings me into a different kind of listener. In this case, it's adding a mouse motion listener, and it's creating a mouse motion adapter, and it's overriding a method called mouse moved. And so in here, we can say mouse moved. And now anytime I'm on this button and I move my mouse, I get an event. And if I move really fast, I get a lot of events. And it's up to, you know, whatever the time resolution of your system is. If your system is very bogged, you may move from here to here before it notices, right? But you're going to generate a lot of events this way. Now, if I'm outside the button and I move, I'm not getting any messages because I only put a listener on this button. But as soon as my mouse is over this button, it starts generating events. And I'm not clicking, I'm not holding my mouse button down or anything, I'm just moving the mouse. Now, if I do hold down the mouse button and I move, it doesn't generate events because this is a mouse dragged event that's happening right now. That's what happens when you hold down a button. But if I release that button and I move, I generate events. Now I can hold the shift button and move, or control shift, and so on and so forth. Those are modifiers to the mouse motion. Alright, so let's take a look at this mouse event. I feel bad because I never read these things on the top, and I probably should. So mouse events have methods like, you know, get button, tell us which button is pressed. Get a click count. If we were scrolling our wheel, we can tell how many times the scroll wheel clicked. Get a point, return the XY position of the event. Well, we can also, you know, get X and get Y to get the XY position. But what is a point? We deal a lot with XY numbers, coordinates, when we deal with graphical elements. And, you know, having one thing is sometimes easier than having two. So there's a class called a point. And really all a point does is it holds a pair of integers, x and y. And you can construct a point, you can get the x and y values and so on, but it's really just a holder. So it's a really simple structure that, you know, if we want to return a pair of integers, x and y, we can just make them into a point and return that point. So it's just another example of that. So we can get the position of the mouse as a point, or we can get the individual x and y. So let's look at the coordinates. So our mouse event is called E. So let's just get the x coordinates. So we'll print out a parentheses, x coordinate, comma, y coordinate, and the closing parentheses. So we'll just print out coordinates of our mouse. And so let me drag this back over here. And if I move up here, I get numbers close to 0, 0. As I move to the right, my x coordinate increases. As I move down, my y coordinate increases. So 0, 0 is in the upper left. Alright, so here's a sidebar on coordinate systems. Cartesian coordinates, x goes to the right, y goes up. Most computer systems do things a little backwards. Y goes from top to bottom. Origin is in the upper left. And this is backwards from how we learn coordinates usually. Cartesian coordinates, x increases to the right, y increases going up. Computer coordinates almost always flipped. 0 starts at the top. Possibly to some degree a holdover from the way that early computer graphics was done, where you basically had a raster scan moving from left to right quickly and from top to bottom slowly. And so the lower y values corresponded to the beginning of the sweep, and as you increase, the y values would increase. Why does that happen? Because that's how TVs work, right? TVs sweep an electron beam from upper left to upper right, and then move down and sweep from left to right, and slowly move from top to bottom. And then when they get to the bottom, they put in a blanking signal to turn off the electron gun, and they fly back to the upper left corner. Why do they do that? Probably because the people who designed them read English, which reads from left to right and top to bottom. So it's another one of these Roman chariot wheelbase things, right? This is why Java does y coordinates like this, probably, to some degree. So this takes getting used to. Right? At least for me it did, because I'm so used to y going from 0 up, and stuff was always coming out upside down. But after a while it flips, and it'll seem like second nature. All right. So we got y coordinates 0 at the top, increasing to the bottom. And again, once I'm outside my button, right, I'm not picking up those motion events anymore. But inside here, I am. Oh, I closed my camera. Oh well. I'm still here. Alright, so get x on screen. So return the absolute horizontal x position of the event. So these coordinates that we were seeing were relative to the button. But let's do... well, on. Let's do absolute coordinates. So I'll bring this in here, and you can see my coordinates are much larger, even though I'm at the upper left corner. My x-coordinate is 4600, and my y is still nominal. If I bring this button down to the bottom of my screen, my y-coordinates are much bigger. And if I bring it way over here to the lower right, my x and y coordinates are, 5700 and 1000. So these are screen coordinates. They're no longer relative to this particular button. They're where I am actually on my entire display. And so I have two monitors set up. So this monitor begins with x around 3800. And if I move this over to my other window and I bring it up to the upper left, right, I can get my coordinates pretty small. Right, so that can be useful. Look outside the box, basically. See, I'm just keeping my window back there so I can restart Eclipse quickly, because, like I say, it's been crashing a lot today. Although a lot less this afternoon than it was this morning, if you can believe it. Alright, what else can we do to our button? Let's add a mouse wheel event. So mouse wheel moved. So we can do wheel motion. And you can't see me doing this, but I'm scrolling my mouse right now, and I'm getting wheel motion events. And that's a mouse wheel event that's being passed as an argument. So you can look that up. And if we look at the methods available for that, we can get the wheel rotation. That's the number of clicks the mouse wheel was rotated. So let's look at get wheel rotation. Run that. So now if I sit here and I scroll my wheel up, it tells me wheel motion is -1. If I scroll down, wheel motion is 1. And when you're playing with these, sometimes you just want to print out like the argument and use its toString method to see what's available. So I can scroll up, for example, or scroll down, and if we look at this, you can see it gave me coordinates. It gave me absolute coordinates. It told me if I had any buttons pressed. It told me the click count. Told me it was a wheel unit scroll. Tells me what the scroll amount is. So this I can set up in my operating system. Right, how many clicks do I want a mouse wheel to move? So I've got it set to 3, and all kinds of other information, right? And anything you find in here that seems useful or interesting, right? There's probably a method either here or in one of the inherited methods that will get you that information. Okay, so that's just a button. Okay, and all of these things we can do in other objects as well. So we could click on the J panel itself and say let's add a mouse motion for mouse moved. And I'm just gonna copy some code. Right, so if I move in my button, I get that, but if I move in my J panel, right, I get events in a different method. If I move in my edit box, I don't get any of those events. So you can set up a slew of different events on a bunch of different components, and you can do whatever you want in those. So you have complete access to what's going on in and around your GUI window, right? And that's going to be fun when we're playing with PA4 as far as figuring out what you want to do. PA4, you're going to have a lot of freedom. I'm going to let you basically come up with your own design for whatever game I pick. So you can choose the look and feel and how it's going to behave and so on and so forth. So you can lose yourself for sure in exploring all these different options. That's not a bad thing to do. Alright, I'm going to shrink my big button because it's kind of hogging up the real estate. Let's play with, let's do radio buttons. So there's a radio button, and there's a radio button, and there's a radio button, And let's take this first radio button and let's make that selected. So I'm going to change selected from false to true. So that button has its circle on it. And if I run this, right, there's my 3 radio buttons. They each have a little circle next to them. Well, the way it's set up right now, I can you know, click all 3 of those, or none of them, or 2 of them, and so on and so forth. So why are these called radio buttons? What do they have to do with radios? Yeah, which goes back to, let's see if I can find you a decent picture. Well, it's not a great picture, but there's an idea, right? So, you know, old radios, especially in cars, they look like this. Because you're driving, you don't want to fiddle with a knob, right? So they had push buttons. And you could lock in a station by, you know, using your dial to pick the frequency of the station you wanted. And then you could pick one of these buttons, you could pull it out and push it in all the way, and it would mechanically link that button to that position of the tuning dial. And so you could press this button and your needle would move to whatever station you had locked in there. And typically this button would then be, you know, depressed. It would be pressed in so you'd know which button you had pressed. And then if you pressed a different button, that first button would pop out and the second one would push in. And the way these were mechanically designed, right, only one button would be pressed in at a time. And if you chose a different button, the previously selected one would get unselected. Right? And that's what radio buttons do in GUIs. Basically, you can choose one and only one and exactly one at a time. And if one's already selected, it will get deselected. Right? So this is an implementation of, you know, old automotive technology. But our button's not working that way, right? So this is sadness, right? Well, easy fix. Right click on your first radio button and say set button group. And it doesn't belong to a button group yet, so let's just make a new standard button group. So we've got a button group here called button group, right? So I'm going to right click on my second one, I'm going to say set button group, and I'm going to set that to the same button group. And I'm going to right click on my third button, say set button group, and I'll set that to the same. And now all 3 of these buttons are in the same group called, imaginatively, button group. And now if I bring this over, when you click one, the previously selected one gets deselected. So now they actually work like radio buttons. So those are handy, you know, if you have a set of options that the user can choose from, but you only want them to choose one option. So do you want to be player A or B? Well, you don't want to have them pick both, right? So they can choose one and the other one gets deselected. So a simpler version of that is just a plain old checkbox. And a checkbox, right, you can just check or uncheck. And the default action when you click it is to just toggle the state. But checkboxes, typically if you have a bunch of checkboxes, you can check all or none or some of them, and that's perfectly legit. All right, let's respond to a checkbox change. So I'm going to go and add an event handler. And I'm going to do state changed. I saved. All right, I'm going to right click on here. I'm going to add an event handler, and I'm going to do change state changed. All right, so I've got a piece of code down here. Let's do a print line. So I'll just print out a message that says checkbox, and sure enough, every time I check the box, I get a checkbox message. I seem to be getting a lot of checkbox messages. All right, so how do we figure out what the state of the checkbox is? This is a little non-obvious. So we're past a change event, which is E. So E has an option, a method called getSource. And that will return the thing that caused the change event, in this case a checkbox. And a checkbox has a method called isSelected. But getSource is funny. If you look at a change event and you look at the getSource method, it returns an object. Right? Now the thing that caused this change was actually a checkbox, but change event is a much more general purpose method. And so we have to do some casting here. We have to say, take this result from getSource and change it to a J checkbox. So putting a type in parentheses in front of something changes it to that type of thing. And so now this thing is a J checkbox, and the J checkbox has an isSelected method. And so I can do something like Boolean cell equals that thing. And let me put my print line down here. And let's print out the value of this. So now I can come in here on a checkbox, and if I click it, it'll tell me checkbox selected is true. If I uncheck it, it'll tell me checkbox selected is false. I'm not positive why it's firing multiple times right now, but I think that's something else I've got set up. But so this is non-obvious code, right? But this is something you end up doing sometimes. With event handlers, you can find the source of the event and then cast it to the type of thing that you know it is, and then you can get to methods in that type of object. And in this case, isSelected will tell us whether the box is checked or not. All right, that's a whole slew of stuff. But it gives you an idea, hopefully, of some of the things that we can do in code or in the designer here to interact with these objects. I had to cast it because a change listener, state change is past a change event. And change event has a getSource method, and getSource returns an object, right? Because change event is used by a lot of different classes, not just checkboxes. And so if getSource returned a checkbox, it wouldn't work for a radio button, for example. So it returns an object, and that's okay because a checkbox is an object, a radio button is an object, right? But you can cast a checkbox that's being treated as an object, you can cast it as a checkbox. In some sense, I think you can cast an object to any other thing, yeah. But very carefully. So there's a whole topic we could talk about inheritance and extensions of classes and how Java allows you to treat some things as other things. But this is mainly where it's going to come up for us, if at all, is when you get something that's really a checkbox but it's being returned as an object, you can just cast it. This happens all the time in Android, by the way. All right. I think we are out of time. All right. So tomorrow, let's dig into inner classes and some of that stuff, and then let's talk about Java documentation. Thursday will be open lab, and then Friday we'll go through PA4. All right. Have a great one. I will talk to you later.